Today we're going to start Unit 2, Lesson 1. This is Introduction to Matter. So our next unit of study is matter. We're going to learn about that today. Remember, as you're doing the notes, to fill in the notes that are missing, the missing words on your notes pages. Stop the video and go to your book to fill in the book questions. And when you're finished, use your visa as your summary, where you're going to write down how long it took you. You're going to do an illustration. You're going to write a summary sentence and ask a question and get a signature. What is matter? Matter is anything that has a mass and takes up space. This is a definition you're going to want to be familiar with. Anything that has a mass and takes up space. So we're going to learn today also what the definition of mass is. So hopefully that will make sense in just a moment. Your body is matter, but light and sound are not matter. The table that you sit at in science class is matter, but your emotions are not matter. Your emotions don't have a mass, they don't take up space. Your table has a mass, you can measure that, and it takes up space. Alright, pause the video, go to page 72 and do question number 6, labeled Identify. What is mass? Mass describes the amount of matter in an object. So matter is anything that has a mass and takes up space, and mass is the amount of matter an object has. The gram, or G, is the common unit of mass. So if we measure how long something is, the unit of length could be meters or centimeters or inches. The unit of measure for mass is grams. Objects of the same size can be made up of different amounts of matter. Weight is a measure of the gravitational force on an object. There is a distinct difference between weight and mass, and we will try very hard not to use them as the same thing in science class. The greater the mass of an object, the greater the gravitational force on that object, and then the greater the weight will be. So weight is a measure of how much gravity is pulling down on your mass. When you step on a scale and measure your weight in pounds, you're measuring how much gravity is pulling down on the amount of matter in your body. The greater the mass, the more gravitational force. So that makes sense. The more mass you have, the more you weigh on a scale. That means the more gravity is pulling down on you. The more gravity is pulling down on you, the greater your weight's going to be. Mass stays the same for an object, even when its increased or decreased gravitational forces are going to change the weight of the object. So for example, if you go to the moon, gravity's less there. Gravity's going to be pulling on your mass less. If you were to weigh yourself on the moon, your weight would be less. However, your mass would still be exactly the same. You're still made up of the exact same amount of matter as you are on Earth. It's just that your weight is a measure of how much gravity is pulling down on you. So you go somewhere that has less gravity, it's pulling down on you less, but your mass stays the same. If that is confusing to you, you need to write down on your visa questions, explain mass and weight more. Alright, I want you to pause the video, go to page 73 and do question number 7. If you're confused about what I just said, you can also read the section here called How Does Mass Differ from Weight? See if that enlightens you. If it doesn't, make sure you write that on your visa to ask me in class. How are mass and weight measured? A triple beam balance is what we use to determine mass. The balance compares the object's mass to countermasses. So we have masses that are of a specific mass, maybe 10 grams, 5 grams, and we use the triple beam balance to move those masses over to increase the mass until we get it balanced out. Weight is measured with the spring scale. So if you step on your bathroom scale, that's a spring scale. There's a spring in there, and it measures how much gravity is pulling down on you. The more gravity is pulling down on you, the more the spring is depressed or goes down. The more it goes down, the higher your weight is. The standard scientific unit for weight is a Newton. We commonly use pounds. 100 grams mass weighs approximately 1 Newton on Earth. So if something is 100 grams mass, its weight is 1 Newton on Earth. Here's a picture of a triple beam balance. If you can see, it's called a triple beam balance because there are 1, 2, 3 beams. Okay, so there are 3 beams. We have one in the front, one in the middle, and one in the back. And you will actually get an opportunity to use this in class. Measuring space. How is the amount of space occupied by matter measured? Volume is the amount of space an object takes up or occupies. Volume is how much space something takes up. A balloon and a bowling ball of the same size have the exact same volume, but very different masses. So remember, volume is just how much space an object takes up. If the bowling ball and the balloon take up the exact same amount of space, it has the same volume. However, if you were to put them on a balance and find the mass, you would see that the bowling ball has more matter, thus a higher mass. Alright, I want you to pause the video, go to page 75, and do question number 9, define. Here's your example of the bowling ball and the balloon. How can volume be determined? Volume can be determined by a formula if it has a well-defined shape. So if it is a rectangular solid, like the picture here, if it is a rectangular solid, then we can determine its volume using a formula. The volume formula for a rectangular solid is length times width times height, or V equals LWH. I bet a lot of you already know that. To calculate volume, all measurements must be in the same units. So if we're going to measure the volume, calculate the volume of this cube, A, B, and C must all be in the same units. So centimeters or inches or whatever we're using, they must all be of the same unit. Another way of determining volume is if you have something that's irregularly shaped, you can use a liquid volume measurement. So liquid volume is measured with a beaker or a graduated cylinder, and it's usually measured in liters or milliliters. So you've already used a graduated cylinder to do thinking like a scientist. You measured out 5 milliliters of liquid oil, I believe, and 10 milliliters of water, or 15 milliliters of water, something close to that. So you've already used this. So you can use a graduated cylinder or a beaker. You fill it up. First, the conversion is 1 milliliter equals 1 cubic centimeter. They're the same. They have an equality to them. The displacement of water in the graduated cylinder can be used to find the volume of this irregularly shaped solid. So you're going to fill up your graduated cylinder to, let's say, 15 milliliters, since you can see the 15 clearly marked in this picture. And then let's say you're going to add a rock. You want to know the volume of a rock, and it's not a rectangular solid. It's round and weird shaped. So you're going to fill up your graduated cylinder to exactly 15. When you drop your rock in, it goes up to 20. To figure out volume, you simply take your ending volume minus your beginning volume. 20 milliliters minus 15 milliliters. That means the volume of your rock would be 5 milliliters. Do page 77, all of question number 11. It's going to walk you through this step by step, figuring out the volume of this locker, which is a rectangular solid. So you can use your length times width times height formula. Packing it in, what is density? Density is a measure of the amount of matter in a given volume. So now you see we're putting together the two things we've just learned. We're putting together matter and volume. So mass and volume. The density of a substance remains the same no matter how much of that substance you have. If you have a half a cup of honey or 3 cups of honey, the density of honey is going to be the same. How is density determined? Common units for expressing density are grams per cubic centimeter, or G over centimeters cubed, or you'll also see grams per milliliter, or G over milliliters. The equation for density is D equals M over V. So you're going to take the density and then divide mass over volume, and that will find your density. Density equals mass divided by volume. Take your mass number, divide it by your volume number. In water, which has a density of 1 gram per milliliter, objects with a density greater than 1 gram per milliliter will sink, and objects with a density less than 1 gram per milliliter will float. So you can see this picture down here of smiley faces. How tightly packed matter is the density of something, the amount of mass in a given space. So gas is less dense, it's not very tightly packed. Liquid, which is a different state of matter, is a little more tightly packed. You can see they're getting closer together. A solid is the most dense. They're very tightly packed. They're just vibrating side to side. Alright, please go to page 80 and do You Try It, question number 15. And then you cannot click on this picture to hear an awesome song because this is a video. But if you remind me today the next day we have class, we'll listen to this awesome song. Don't forget to fill out your visa when you're finished.